Hello and welcome to Math Matters. Why do I need to know this? This is a program where we look at the entry-level mathematics that we teach here at Western and try to apply that to everyday life. I've got some neat examples I want to show you today that deal with everything from consumer math to just general kind of allocation of resources kind of things. So let's get right after it. The first thing I'd like to talk to you about today is I'd like to say a little bit about amortized loans. Now, that's probably, it could be a word that you're not familiar with, but basically what I'm talking about is a home loan, okay? Most folks, I think, now you're maybe too young to worry about it right now, but most folks are going to, at some point in their life, own a home. And chances are you're not going to be able to just walk up and pay cash for it. If you had to do that, nobody would have a house. Donald Trump would have a house and a few other people. So you get a loan and you end up using the house and the property as collateral. That is, that's called a mortgage. And then the types of mortgages that are available, most of those are what are called amortized loans. And that just simply means that you've got regular scheduled payments that include a payment to both the principal and the interest on the principal. And even along those lines, you have some choices as to what you're doing. The most common type, I believe, would be the equal payment type of amortized loan. The payments, obviously, the name says, are equal. But what happens is the percentage of that payment that goes to principal and interest changes throughout the life of the loan. You start out paying quite a bit of interest because you owe a lot of money. And then as you start to pay off the debt, you have more and more of the money going to pay off the principal and less of it going to just pay interest on what you owe. But the payment itself stays the same. It's just through the life of it, the amount that goes to each changes. Another approach to doing this would be what's called an equal principal type of amortized loan. Okay, the idea here is that you simply take whatever amount you borrow, divide by however many months you're going to have this loan, and you're going to pay that amount of principal every month. Then on top of that, you're going to pay interest on what you owe. So as throughout the life of the loan, the amount you pay to principal stays the same, but then the amount you pay to interest goes down. So the payment actually goes down throughout the life of the loan. And that's an okay way to do it. Most folks still, I think, kind of prefer this equal payment thing where they have just the same payment throughout. They lock in their interest rate. There is another scheme to do, and I say scheme because I'm not real big on this idea, but there is this idea of reverse amortization. And what that means is you start with low payments. This is something that might be done for somebody who's having a hard time affording a house right now. But you start with a very low payment, and it's initially, that payment is actually less than the interest you owe on the amount of money you've borrowed. So what happens there, because your interest is less than what you actually owe, the part you're not paying gets tacked on to the principal. So the payments over a period of time go up, and you end up having to pay interest on more than you actually borrowed. You're kind of betting on the future that you do something good and you're making lots of money. It's legal. Just understand that you could be getting yourself into a bit of a fix there. The one I want to look at today, because this is the one that's actually kind of difficult to calculate the payment for, is this equal payment type of amortized loan. We actually did something similar to this last week. If you go back and check episode 10, we talked about a person who had a balance on a credit card. They quit using the card and they wanted to pay off that balance within, however many regular monthly payments. And so we did a bunch of work actually last week. I'm not going to go back and kind of show you where this formula comes from, but we said, all right, well, the amount you'd have to pay per month then is X, and it's based on these amounts. The A sub 0 is the initial amount, the first balance. This M is the monthly interest rate. So you take the annual rate, R, and divide by 12 to get that, and then N is the number of payments you want to make. Okay? That's exactly the situation we're talking about. You've got money borrowed, you're having to pay interest on the money you've borrowed, but you're reducing that amount every month. So it's the same formula, same situation. So let's say that here's an example, you're borrowing $100,000 at 6% annual interest over 30 years. So the monthly rate would be 0.5%. And if you go through and you plug all these crazy things into the formula, 1 plus this will give you that, the number of payments would be 12 per year for 30 years. So that's 360, I think. This works out to be $599.55. Now, that works out so that over the life of the loan, that last payment is almost exactly the payoff. There's a little bit of rounding involved. The actual payment would be probably more than that. You have to realize that most folks, when they do this, they put stuff into escrow. They store things there like real estate taxes, homeowners insurance, sometimes even mortgage insurance, depending on what your down payment was. So the thing is, if you take that amount multiplied by 360 payments, you've actually paid back over twice what you borrowed, $215,000 plus. That's scary, but that is just kind of the system. That's the way things work. You're not paying anything you didn't owe. You had a lot of money borrowed, and so that's in the process of paying it back. That's what you're paying back. How can you lower this amount? Well, you can do this. You can borrow over less time, set this up for 15 years instead of 30. What changes in this formula would be the 15. And that gets you up to a monthly payment of $843.86. Now, this is the prohibitive part of this. That may be too high. You may not be able to afford a house at that price. So you will end up spending less money over time, but you have to spend so much per month, it may be prohibitive. I think that works out to, about $150,000 you pay back. So you're saving right at $64,000, but that's, again, you got to make that payment. The other thing you can do is you can add a little bit to each payment, and this is kind of like going in between. Your monthly payment is this, and if you graph this crazy thing, the blue curve here is this thing in terms of N, and then right at 360, that's where we hit this level of $599.55. If we add $10 each month and bump that up, well, the curve moves, it hits the curve a little bit to the left, and it's more like 344 payments to do that. It shortens the loan by 15 months. I say 15 instead of 16 because there's a little bit of stuff left over. You'd have to actually go another month to pay it off. But you're going to send in an amount that's about $6,000 less than just if you did it the standard amount. If you go 20 over per month, it'll take it down by about 30 months, and you've saved about $11,386. The good side of that is that you don't have to make the big payment unless you want to. You're kind of tacking on when you want to do things. So it's not a bad system, actually, to get the longer loan and then pay it off in a shorter amount of time. I flashed up a bunch of stuff very quickly there, so let me put up some summary pages to kind of cover what we talked about.